equation like a linear, that was last year with this other one, or like a quadratic this year with meat. And being able to be skilled in it and be able to use it. Be skilled and be able to use it. How many of you guys are in woodshop? Let me see, real quick, hands up. What's the first? That's it? No one else is in woodshop? Only 2? Okay, in woodshop. Question, do you walk in there the first day and Mr. Horn's like, hey, skill saw, let's go?
No.
Heck no, Chuck, no. You're going to be like chopping off either your fingers or someone else's fingers. Maybe even some toes. Like, no. You have to become skilled at the basics before you can be given, right, the more advanced tools in anything, whether it's woodshop, whether it's, hey, you walk in, you're like a little itty-bitty elementary kid. You have like a basketball and you're like, yay, and they're like, hey, sweet, let's work on your form for 3s. No. Teaching you how to set screens. No. You start with the basics. Here's a ball. Let's talk how to bounce, right? There's a hoop. Let's kind of get you guys, let's bring the hoop down a little bit because we don't want to mess up your form and have you doing some weird, crazy stuff you're not going to do in your older. Anyway, you have to start with the basics. So with quadratics, we started with the basics in lots of ways. Factoring, okay, I know, factoring was hard, it was nasty, but we keep on practicing it. But the basics with all the graphs, that was the basics. We got to build up, but to build up, radicals. Okay, and letter A. You guys just help me out. Let me zoom in on this. This page is nothing new. This page is nothing crazy, but it is radicals that some of us aren't so hot at, and we need to get better. We need to get skilled at. In Algebra 1, we're building a lot of the foundation so that you can have skills to be able to advance even farther in future classes. So what do you guys see? Does anybody see anything in these first A, B, C, D on your paper that you know right off the top of your head? Some of you, yes. Some of you are like, I'm not so good at these, but what do you see? Okay, there are lots of square roots. Does anybody know any of them? Not like the answer must be just a piece. Danny? Oh, we can just go by the pieces. B is 10. How'd you get that?
36 plus 64 is 100.
Okay, so Danny, he's doing PEMDAS. He's technically doing parentheses. He's seeing the square root as a grouping symbol, and he did the addition to figure out 36 plus 64 was 100. What's the square root of 100? 10. He's totally right. Have you guys filled it in? He got you an answer. What's something else someone sees? Doesn't have to be the final answer, just a piece. Just a piece. Square root of Jonathan, what do you know?
36.
Okay, so we can go ahead and put a 6 here, right? And a 6 here. But that's not the entire thing. Anybody know the square root of 64? 8. Good. 8 times 8. We have 8 and we have 8. Okay, so what is 6 plus 8? We can finish that off, right? 14. Good. What's 8 minus 6? 2. There you go. Now hold on. We're avoiding the subtraction because a lot is, it's not even like an easy 2-column subtraction. We're going to have to do some borrowing. We're going to have to do 14 minus 6, right? That's all right. We just said 14 came from 6 plus 8. So 14 minus 6 is 8. 5 minus 3 is 2. Is that right? 28? I think so. What's the sad part about it being 28? I liked 100. 100 was nice because the square root of 100, Danny, was what?
10.
But what's the square root of 28? It's forcing us to remember, wait a minute, not all square roots are nice and neat and pretty. What did we do before with square roots earlier this year when we couldn't just make it a nice, neat answer to the number underneath? We divided, we factored, we broke it down. So 28, does anybody know now? Sometimes we take 28 and we break him all the way down to saying you're even, let's divide by 2. You're even, let's divide by 2. Sometimes we do that way. Divide by 2 again. Oh no, no more 2's. Only 7 goes in. We can do it that way. Some of you are more used to the factoring tree though, instead of the boxes, and the factoring tree would say, what goes into 28, guys, that you know? Yeah, most people wouldn't think 2 and 14. Most people would think 4 and 7. So, instead of going that route, we could just say, okay, 28 is... Do you remember what we would do once we saw the 4? Max? We could keep going down. We could make the 4 into 2 times 2. But that 7 would be stuck, right? Once we break down 28 all the way, there are two different ways of breaking down 28. And remember, the 28 has a square root. We could make the square root of 28 the square root of 2 squared times the square root of 7, or we could make it the square root of 4 times the square root of 7. Do these mean the same thing? What do you guys think? Yeah, 2 squared is 4. But which one looks easier in your brain to do, even though both of them will take you to your right answer? The one on the left or the one on the right? It depends on your brain. Some of you remember that to cancel out square roots, I just need a square, or any multiple of 2 in the power. Some of you are like, I know the square root of 4, it's 2. So I could say 2 rad 7 is the answer. But couldn't you have also have crossed out the square root because of the squared, and also said 2? When I say rad, I mean radical, and radical is that square root. Either way, you get 2 to the square root of 7. So what's on this page? This page is reminders that some square roots you should know. So let's go through the squares really quickly. What's 1 squared? Oh, we gotta get everyone answering, else it's no fun. And some of you don't know all your squares. So what's 1 squared? 1. What's 2 squared? 2 times 2. 2 times 2. 4. What's 3 squared? 3 times 3. 9. Yeah? So what we're doing is all the squares. 1 squared, 1 times 1. 1. 2 squared, 2 times 2. 4. 3 squared, 3 times 3. 9. Have you guys never gone through these before? Maybe not. What's 4 squared? 16. There you go. Now you're thinking ahead. What's 5 squared? 25. What's 6 squared? What's 7 squared? What's 8 squared?
64.
9 squared?
81.
10 squared? 100. Oh, 11 squared?
122.
121. And then 12 squared? 13. 16. Put it together. 16 and 9. 169. 14 squared? Anyway, we're done.
Right?
So we've heard 1 and 4 and 9 and 25. Oh, missed 16. 36. 49. 64. 81. 100. 121. 144. We love those. Everybody else, you gotta break them down. We have some more example ones though. Are any? Oh, some of these.
36.
Oh, guys, they're easy. How'd you get 36?
Not that one.
Oh, this one or that one?
Not that one, yeah.
Oh, yeah. Because you did the under parentheses, the PEMDAS, yeah? And then square root of 36, that's a perfect square. 6. Okay, but what about this one? No. Don't go to 36. How about 2 times? Wait a minute.
Oh.
They're the same. Can you guys draw an arrow and just put a little check mark? They're the same. Oh, that's kind of cool. A and B weren't the same. C and D weren't the same. But E and F are. Hey, how about letter G? Does anybody know if you have 100 cents and it's cut into fourths? How many senses do you have? Cents do you have? 25. Some people are like 100 divided by 4. I don't know, but it's like 4 quarters and $1. Oh, I didn't. Okay, what's the square root of 25?
5.
Got him. Wait, but doesn't 100 have a square root? And that's 10. Doesn't 4 have a square root? What's 10 divided by 2?
5. Wait.
Oh, draw the arrow. Bloop, 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 check mark. What am I trying to show you? Yeah, it can be, well, hold on. What can be written different ways? Addition and subtraction? Multiplication and division. So what I want you guys to do, especially if you have a highlighter, is to go ahead and circle E, F, G, and H. E, F, G, and H. And if you want to write off to the side, actually, it's not even right words. Let's just write symbols. It's faster, it's easier, it's simpler. Multiplication and division with square roots can be split up. Multiplication are a yes. What is a no? Yeah, if you want, you can draw your arrows and be like, it doesn't work. You can draw your arrows and be like, it doesn't work. Addition and subtraction, you cannot split up. Multiplication and division, you can. Now, I know that might seem so basic to you, or so like inconsequential, like what's the point? But I have kids in calculus AB AP calculus. They've been doing that for a long time now, and hard math too. And they still mix up the addition and subtraction that can't versus the multiplication and addition, multiplication and division that can't. Something so basic that we're learning way back when, now in Algebra 1, that if you don't get solid now, it'll mess you up later. And just imagine, just a second ago, do you remember x equals negative 8 plus or minus square root? It's a huge formula. If you don't know how to do radicals, even if you know the formula perfectly, you're going to mess up every single answer. So see, it's important to know how to do the pieces, and this is one of the most important pieces for radicals. Addition and subtraction is a no. Multiplication and division is a yes as far as doing that. Okay? Let's keep going. If you guys take notes, here's the first page of notes for today. But it's also leading into the 1, 2, and 3 that are blank. It's okay, we'll fill them in. That are blank, and we're going to solve. If you don't take notes in a notebook, I'm actually not making a big deal about that this semester. I think it's still helpful. I think it's still important. I think it's still good. But if you don't have a notebook, if you don't have a place for taking notes, take it on your worksheet. Take it on your worksheet. You can put it on the back if you want, or you can maybe even fit it in right next to these problems, because I think there was a little bit of space over here to the side. But it's up to you. There's room on the back, but there's also room next to the problems. Because look at the directions. Doesn't it say determine whether the expression is in simplest form? I want you guys to circle simplest form. Circle simplest form. Because how are you going to know unless you actually know what simplest form is? Well, yeah, start by circling it. Your brain, simplest form. But what is it? Check it. That's why I have the notes. That's why I have the notes. What is simplest form? Max. Oh, make it a little bit bigger?
Yeah.
Is that better?
Yes.
Got it. 3 things. And not all 3 things are necessarily present in every problem. It's just 3 things to look out for. Whenever it says no, you just have to be like, okay, if it's there, it's a no. No? Oh, some of you forget what radicans are. Some of you forget what radicans are. Let me do a quick little labeling as you guys are writing. That way you can know what these terms are. So we have what's called the radical sign. The radical is that square root sign. It could also be a cube root, or it could also be fourth root. But then you also have whatever is underneath. You also have whatever is underneath. I'm going to do something crazy like 4x squared. This is what we call the radicand. This is what we call the radicand. Radical is what's on the outside. Radicand is what's on the inside. So no radicands. No insides, if that helps. No insides have perfect nth powers as factors other than 1. If you want to circle something, perfect nth powers. We have to get all perfect nth powers out. Meaning, square root of 28, just a second ago, there was a 4 inside. We had to take his square root because we knew it. That 4 was a 2 squared. We could take the square root of 2 squared. We have to get out anybody who has that perfect nth powers. If you're like, nth, well, nth is whatever little guy is the index. If it's a square root, there's nobody there, but it's an understood 2. If it's a cube root, there's a 3 there. If it's a fourth root, there's a 4 there. For the square root, we're looking for squares. If it's a cube root, we're looking for cubes. If it's a fourth root, looking for fourth powers. No radicands can contain fractions. Here's another way of putting that. Here's another way of putting that. No denominator in a radical. What that means is no denominator can be in a radical and be in simplest form. No denominator can be in a radical and be in simplest form. And then last but not least, oh, wait a minute, that's what the last one says. Just kidding. Sorry, I made you write it twice. No radicals appear in the denominator. So no fractions are underneath the radical, and no radicals are in the denominator. So I'm going to write a few things. What if I was to give you something like the square root of 17 for number 1? Go ahead and write it in because the problem's missing. For number 2, what if I was to give you the square root of 32? And then number 3, what if I was to give you something like the square root of 5? Let's do 25. No, let's just do 5. The square root of 5 over 2. Which ones are in simplest form? You just put yes or no. Number 1, what do you guys think? Simplest form, yes or no? I see a yes. I heard a yes. I heard a couple no's. I see some thumbs up. Why are you guys giving me a thumbs up? No fractions, no denominator with the square root, but can you break 17 down? No. It's 1 and 17. I can't take anything out. Simplest form. It's perfect as is. It's done. That's as far as you can go. Box it and be like, ha, that would be the final answer. No farther to go. Unless they want a decimal, then put it in your calculator. How about number 2? Yes or no? No. I heard Jeremy start to say yes. You said no because you said, wait, 4. He said 4. Why did he say 4? Because 4 goes in, and who is 4? A perfect square. Yeah, he has a square root. What's the square root of 4?
2.
Close. 2, right? So 32, just because 32 has a 4 in it. Now, actually, 32 is kind of crazy because he doesn't just have 1 4 in it. He actually has 2 4s.
Oh, wow.
And there are a couple different ways of writing 32. One way is to rewrite him as the square root of 16. 4 times 4 times the square root of 2. And if I had rewritten them like that, maybe a lot of you guys, instead of looking out the back window, would see that the square root of 16 is 4, and he can be ever broken down more. And his final answer would be 4 rad 2. Some of you would have maybe done that a different way. You would have kept going and gotten more 2s, more 2s, more 2s, and there are tons. You could have square rooted that guy, you could have square rooted that guy, and he would have been left on his own. That poor little guy's out here. But either way, yes, he can be broken down. Since he can be broken down, yeah, the answer's no. The answer's no. He's not done yet. How about number 3? He's in yes or no? He doesn't really fail this one. At least not until we rewrite him. He doesn't really fail this one because the 5 can't be square rooted or broken down. The 2 can't be broken down. But is there a fraction underneath a radical?
Yes.
So he's a no. There's a fraction under a radical if there's a square root in the denominator, or if there's somebody who can be broken down where there are perfect squares, those are going to be no's. Guys, that's where homework starts. You can see it in the backboard. 5 through 9 is just looking and saying, is it in simplest form?
No.
Is it in simplest form? But hold on, there's a little bit more to your worksheet, right? So if you take notes, I'll dual screen it. If you take notes, look at the bottom part of the worksheet. We're just going to play with it. The bottom part of the worksheet says simplify, right?
Right.
Simplify. Well, how do we simplify? So let's say we don't have fractions. We're not exactly ready to deal with fractions quite yet, unless they're nice and easy ones that can be broken down fast. If we don't have fractions, which is the beginning, isn't that the 4, 5, and 6?
Yeah.
If we don't have fractions, we're going to factor out any constants. We're going to break down and pull out any constants we can and any variables we can. We're going to here's my way of saying it. Break down whatever you've got. Break down the numbers, break down the variables, and pull out the groups. If there's anything with a perfect square, for right now, we're not even doing cube roots yet. If there's anything with a perfect square, if we can pull out the groups, do it. Pull out the groups, aka, if you want to put another way of saying that, simplify any perfect squares for right now. We're only looking at square roots right now. Simplify any perfect squares. If you see a 4, if you see a 9, if you see a 16, if you see a 25, if you see something squared, you can pull it out. Ooh. Sorry, mine are really small, but you guys can see yours. I'm going to zoom in on this in just a second. A couple people are still taking notes. Can you guys look at those numbers under those square roots? And I want you guys to tell me which look easier to do. 4, 5, and 6, or 7, 8, and 9.
4, 5, 6.
You would think. But now look at the numbers. You looked at the fractions, no fractions. You said, ew, I don't like fractions. But wait. Look at 7, 8, and 9 one more time. Look at 7, 8, and 9 one more time.
7, 8, 9.
Why?
Because
They're fractions, but that's not why they're easy. They're easy because you guys just see with multiplication and division, I can split up radicals. Can you guys go do that for all of them? Go do that for all of them. Because all of them, we can split it up. We can take one nasty ew, it's a radical of the whole thing. And we can say, no, it's a radical of the top. And it's a radical of the bottom. It's a radical of the top. And it's a radical of the bottom. Do any of those look like nice numbers that we don't mind being under square roots? What's the square root of 9? What's the square root of 25? Oh my goodness. Guys, that's like the easiest one on the whole, not the whole page, but kind of. Okay, wait. But number 8, hold on. What's the square root of 64?
8.
But what about that top? Why am I just rewriting it? I can't break it down. And is there a square root in the denominator? No. So I'm okay. I can stop there, and that's legal. How about number 9? What's the square root of 4? What's the square root of x squared? The square root and the squared can simplify to be an x. Now, what did we not look at? We didn't look at the ones up above. So does anybody, because they know 50 is 2 quarters? And we like 25? Because wait, so I could rewrite 50. I don't even have to keep going. Can I just break down the square root and say the square root of him is the square root of the multiplication? What's the square root of 25? You're looking for those perfect squares. 1, 4, 9, 16, 25. You're looking for those perfect squares when you break down your numbers. So how would we finish 5 and 6? Those are the 2 that are going to be like our warm-up tomorrow. Break them down. Guys, you have all that you need to do homework. I can put it up here on the screen if you guys want to take a picture of it up front. Or a picture on the side. Homework 9.1a due tomorrow. Bye, get out of here. See ya. Thank you so much for trying to be quiet today. Ow! Would you like?
School class, you're not sure? I just didn't check, but thank you.